I'm Wendy Zuckerman, and you're listening to Science Versus. And today we're pitting facts against film. While we're working on episodes for our next season, which I'm very excited about, we're just firming up what we're going to be tackling. In the meantime, we are putting little Easter eggs down our feed. And the egg I am serving up today is poached. By that I mean it's the best kind of egg. Don't tell me scrambled is better than poached. So, Christopher Nolan's latest film, Oppenheimer, just hit the cinemas and it's been going off. This film tells the story of Dr. Robert Oppenheimer, who is sometimes credited as the father of the atomic bomb. Here's some audio from the trailer.
You are the man who gave them the power to destroy themselves. And the world is not prepared.
Now, in truth, the atomic bomb actually had quite a few fathers and mothers. But why let facts get in the way of a good story, eh? Well, to tell us all about facts, this week I had a chat with Professor David Saltzberg. He was a scientific consultant on Oppenheimer. He's also consulted on TV shows like The Big Bang Theory. And before you throw a tomato at him, his job wasn't to write the jokes, just to help out with the science. We talked to David about the science of building an atomic bomb, working on a set with actors and helping them grapple with some pretty tough scientific concepts. And we also discussed why it's so damn important that the stuff written on blackboards in sciencey sounding movies is actually correct. It's a bit of a gripe of mine. If you haven't seen the film, don't worry, there's no spoilers. Well, I am assuming you know a little bit of history. Okay, after the break, my chat with Professor David Saltzberg. Hi, David. Now, welcome to the show. We're really excited to have you.
Hi, how are you?
We like to start with the easiest question. Can you please introduce yourself?
My name is David Saltzberg. I'm a particle physicist at the University of California, Los Angeles, where I'm a professor. And on the side, I do some consulting for Hollywood TV shows and films.
You seemed a little unsure when you said you did particle physics. Are you sure? Have you been in Hollywood too long?
I'm pretty sure I've been doing it since 1989.
Okay. So I guess before you were consulting, have you ever watched a movie or a TV show that involved physics and you just wanted to throw something at the TV screen because they got it so wrong?
Yeah. When I was growing up, all sorts of crazy science fiction that was nuts that my friends and I would laugh at. You know, there was some sort of space drama, like we used to watch Space 1999. And although it was mostly correct, I think I remember one line that another ship was so many hectares off their bow, which is not a unit of distance. And the point was that teenage me and my teenage friends, we got into the science of it just making fun. So it doesn't necessarily have to be correct. And in fact, it's a creative decision. I see my role. I'm here to provide the science fact as needed, maybe to provide some ideas that might lead to stories, but I'm not the science police. It's a creative decision how accurate to be. You know, you could imagine if Back to the Future had a science consultant and they said, well, you know, actually, we can't really go backwards in time. It doesn't happen. Well, that wouldn't be a very good movie.
Yeah. How did you get into the world of consulting for Hollywood?
It's interesting that this just fell in my lap. I was working at CERN.
And this is where the Large Hadron Collider is, the big atom smasher.
At CERN is this big international laboratory for particle physics. And now, yes, it does have the largest atom smasher in the world, the Large Hadron Collider. You may have heard about it 10 years ago when the Higgs boson was discovered there. And while I was there, I was invited to apply to a faculty position here at UCLA. And it sounded great. I really could have wound up anywhere in the country, but I wound up here in Los Angeles, which is the heart of television and film entertainment. And 10 years went by and I had no contact with them other than when I met people socially. And then I was asked through a friend of a friend if I would help out on this new TV show that was going to have physicists as characters. Who knew? Your listeners may be familiar with a show called The Big Bang Theory.
Yes. I'm guessing they either love it or they hate it. Either you're like my mum and you love it, or you're like me and it's not your thing.
And that went on for 12 years. And at that point, one thing leads to another.
And so what do you think, like, little David, like you, as a physics nerd, would say if he could see you now, talking to these big Hollywood types?
I don't know. I mean, in the end, it's like just working with other smart, creative people like I get to do all day. Putting on a show and putting on an experiment aren't really as far apart as you might think.
So once you started working for The Big Bang Theory, and you did it for so many years, what's your favorite cocktail party story about working on that show?
Oh my God, there's so many.
We got time.
I can tell my student, not a cocktail party, let's say, but I can tell my students that I once needed the famous equation S equals 1/2 GT squared, which is how far something falls near the surface of the Earth in a certain amount of time.
Okay.
We were taping the show, and it's taped in front of a live audience, and somebody drops a bottle down the elevator shaft. One of the central pieces of the stage was this elevator, but it wasn't really an elevator. There weren't really 4 floors. So somebody dropped a bottle, and the crash sound, one of the producers says, that's too close. It should take a little longer. And so they said, David, how long should we wait for the sound effects guy to hit crash after when he drops the bottle? And, what could be a simpler equation in physics? We learn it the first week. If you're taking physics, you're going to take 4 years of undergraduate. You learn this your first week. And of course, I was immediately frozen. Everyone waiting. But somehow I got unstuck and we figured it out.
Oh, wow. Oh, was Google of assistance?
No. It all was done in my head.
Did you ever actually get anything wrong?
I did get a nuclear/particle physics equation wrong, or a formula, it's called a reaction wrong, on a whiteboard. I had confused the cascade hyperon with the sigma hyperon.
David, I'm always warning you about that.
And people let me know about it.
Oh, no. I could actually, I'm joking, but I could actually imagine that would have been a day when you got that email. Oh, what was I thinking?
And so it was very embarrassing.
Now let's get on to your work on Oppenheimer. So when you got the call saying, David, can you consult on this? Did you have a sense of how big Oppenheimer was going to be?
I have to confess, while I've heard of Christopher Nolan's movies, I didn't have his name connected to them. So someone told me it was a Christopher Nolan movie, but it didn't quite register what that meant. So I didn't know this was going to be one of the year's blockbusters.
So if Greta Gerwig had called to get you to consult on Barbie, you would have known, this is going to be big straight away.
That would have been a little clearer, yes.
And so for those who haven't seen the film yet, I saw it this week. Oppenheimer tells the story of Dr. Robert Oppenheimer. But really, as I was watching this movie, I was struck by how it was, I don't know, to me it was about how this like nerdy, exciting, theoretical branch of science, nuclear physics, how this branch of science was being born. It just so happened at basically the moment in history when the Nazis are taking power, and how those moments coinciding ultimately led to the creation of the atomic bomb.
It's amazing your feeling for what you're saying that must be like, because I was just discussing this over lunch with other faculty, is it all happened so quickly that these people, Oppenheimer and other people we meet, Bohr, Fermi, the greats of 20th century science, in 1935, they didn't know what was about to happen to them, how important they would be. They were doing interesting science. You only get to explore the workings of an atom once, and they were doing it. Once in history, you get to discover what the atom is made of, and they did it. and they were having a wonderful adventure in science. But they had no idea that that was going to intersect with history, and they'd become some of the most important people in 20th century history.
Can you set a little bit of the scene here? So as the Nazis are getting into power in the 1930s, like, what does science even know about atoms, neutrons?
So what's happening in the 1920s, people are just beginning to probe the nucleus of the atom. By that point, people had just been figuring out that the way an atom was built was a hard inner core called the nucleus, which we now know is made of protons and neutrons. And then very far away is this little light electron whizzing around. So they just figured out what the atom was doing.
So in the late 30s, the Nazis are already in power in Germany. German scientists split the atom, and it's referenced in the film, there's a moment. But in real life, how important was that?
So this is a German laboratory in 1938. Hahn and Strassmann were working in Germany, meanwhile, Lisa Meitner had to leave Germany from her lab because she was Jewish, and they were sending the results by mail. And she's the one who figured out by looking at the chemical properties of what was left behind, these weren't making sense. And she's the one who figured out it must be fission. Very quickly, when people saw there was fission, the possibility, it wasn't guaranteed, but the possibility there could be a bomb suddenly for anyone who'd been studying nuclear physics would become immediately apparent. And that's what we're facing here, that there's this revolutionary discovery that allows you to build an atomic bomb. What's the chance that this happens a year before the outbreak of World War II?
So we've got like the splitting of the atom. How do we go from just like splitting an atom to all of a sudden a bomb?
So you have a uranium nucleus sitting there, just innocently minding its own business. And then we hit it with a single neutron. Neutron goes right in and just gets absorbed. And so what Bohr realized, it would start to wiggle like a little liquid drop. Okay? And there's a small chance that it just breaks into two droplets, just like an ordinary water drop. That was the surprising thing. But when it comes apart, these two nuclei that are left don't need as many neutrons.
Aha. So when the atom splits, basically you end up getting some leftover neutrons that are buzzing around.
Yeah.
And then they end up splitting the uranium atoms that are nearby.
They hit another uranium nucleus, which starts to blob like a water droplet, and it breaks apart. You have one, then you have two, then you have four, then you have 8, and so forth. It's called an exponential process. And the whole thing has to happen fast enough. They didn't know that. When they first saw the first fission, they didn't really know that the whole thing could happen fast enough to make a bomb. But it was a possibility, and they had to chase this down.
Like, how does that first bullet hit the nucleus?
Where does the first one come from?
In the bomb.
So what they actually had was something called an initiator. And so it was some radioactive a little sandwich of two radioactive pieces that didn't produce neutrons until they're mixed. And so you squish them together, and then suddenly a little burst of neutrons come out and initiate the chain reaction.
Amazing.
And so where does that energy come from in the first place? We have uranium sitting here on our planet Earth, holding this energy. Where did it come from? And when the universe was made, it was hydrogen, helium, little lithium, not much else in terms of atoms. So where does uranium come from? In supernova explosions or in collisions of neutron stars, there's an enormous amount of neutrons flying around. And so when you have this atomic explosion, we're taking the energy of a dying star.
Oh my gosh.
And re-releasing it.
I can't think of anything more human than taking something so beautiful as a dying star and then using it to build a nuclear bomb. So in the film, there's this kind of discussion that a nuclear bomb might destroy the entire world theoretically, and they come back to this. And Christopher Nolan has talked about how it was this sort of idea that kind of really drew him to Oppenheimer.
Are we saying there's a chance that when we push that button, we destroy the world? Chances are near zero.
Near zero.
Tell me, was that possible that and how was that theoretically possible that a nuclear bomb could destroy the entire world?
So we're talking about nuclear chain reactions, and they worried if they couldn't stop the chain reaction. What would happen if some chain reaction with the nitrogen in the atmosphere were to be allowed to happen? Then you would essentially ignite the atmosphere. Ignite it in a nuclear sense, but still basically burning it. That would be a very bad thing. It was a very unlikely occurrence. My understanding is it was nowhere close to happening. Now, you can never quite say zero, and they make a joke about that in the movie. If you want a physicist to say there's zero chance, well, we can always come up with maybe another caveat. But this was very unlikely. My understanding, it was as close to zero as you can calculate. By the way, this comes up again in every time we turn on a new accelerator. It's technically a new regime, right? A little more energy than we've ever collided particles before. And there's always someone who says we're going to make a black hole that swallows the Earth or something. It's really not going to happen. But it's very hard to bring ourselves to say zero.
Yes, it really does mirror the conversations that we had around the atom smasher.
Right. Oh, you remember that from about 15 years ago. And that wasn't the first time. It was totally predictable. Every time a new accelerator turns on,
right,
somebody gets a little attention for themselves by bringing up this question.
Because the media will ask some question like, are we about to destroy everything? And a physicist goes, well, I can't say the probability is zero.
A lot of people, the people they let speak to the reporters were the ones who were willing to say zero. I remember talking to a friend of mine saying, well, maybe there's and I was finding small loopholes, and they said, you're not allowed to talk to any reporters.
Get her out. After the break, more on the science of the film Oppenheimer, and we'll hear about the time when Cillian Murphy, who stars in the film, asked David, wait, what does this line mean?
And I looked at it and I was like, oh my God, this is really hard.
Coming up. Welcome back. Today we're talking to Professor David Saltzberg, who's a particle physicist and was also one of the scientists consulting on the film Oppenheimer. Let's jump back in. Tell me a little bit about how it was working on the movie. So with the Big Bang Theory, you were actually, as you mentioned, you were on set there to lend a hand when they needed to throw bottles down elevator shafts. How did it work with Oppenheimer? Were you working with the actors a little bit on those sets? Did they ask questions?
A little bit, and it was sort of by chance. So, for example, Cillian Murphy, who played Oppie, came up to me with a line of dialogue and said, "I don't understand what this means. Would you help me?" And I looked at it, and I was like, "Oh my God, this is really hard." It was super technical.
Oh wow! What was the line?
Oh my God. Do you want me to read it out loud?
Yeah, of course I want you to read that. What's the line?
The optimal elimination of the coupling.
If you could do it in Cillian Murphy's voice, that would be even better.
I don't think I can do it in Cillian Murphy's voice.
David Saltzberg.
The optimal elimination of the coupling between the R states means that not H sub RR prime, but H sub RR prime corrected for the quote-unquote line shifts due to the coupling with the states S is diagonal. Then there's an equation.
I do not remember that line in the film.
No, yeah, I think that did not make it. But I had to go back with the help of Google. I found the 1930s paper it was from, and I actually was sitting there reading it. And then I got to the point where I sort of understood it well enough. And then I tried to tell him, well, this is just kind of technical. He wouldn't have it. He wanted to know what it meant.
You tried to brush off Cillian Murphy with, it's just science, mate. Don't worry about it. What did you tell Cillian?
Yeah, and I have actually some notes here about what I told him. I've got 3 paragraphs here, which I won't read. Okay. But it involved matrices, which are grids of numbers. Like I said, I've been doing this on and off for 15 years. I've always been able to explain to the actor what the line meant at a satisfactory, a real sense, what it is, the satisfactory level of what they need to know. This was the first time I basically totally failed. I could not explain.
So in a nutshell, I'm guessing in a nutshell for us, you can't. Can you even put it in any context of what is this?
I mean, it had to do with the calculation of the rates of certain nuclear reactions.
Okay.
And there's all this bookkeeping for how to do that. And that's what the line was about how he did that calculation.
Okay. Okay.
But it's not even a line in the movie in the end. So,
yes.
That's so funny. This line comes back to haunt me. Never go away.
The ghosts of science communication past will come at you. Now, another one of your jobs was to write some of the blackboards that you see in the movies that the scientists are writing on or talking in front of. And there's a lot of blackboards in this movie. How did you decide what to put on them?
Oh, so so that was an important thing. You can't just put anything on these chalkboards. It would be wrong. For example, at one point we have Oppie talking to students. He had brought back the new quantum physics to Berkeley and also to Caltech. And so it would be a certain kind of math and science on the board, a little technical, written in a way that a teacher would write it. There's another case where Bohr is lecturing to the public. Well, that's going to be a very different kind of thing on the chalkboard. So I did need to take peeks. I was not involved in the script for Oppenheimer, where I am involved in the scripts for Young Sheldon and I was for Big Bang Theory. And so it actually made it a little hard. So they helped me out by letting me see those parts of the script.
Oh, wow. There's so much secrecy involved.
Yeah, so much secrecy that I wasn't supposed to see the script, and I saw just enough to be able to do my job
interesting.
On that case.
But I have to say that the chalkboard is very important. I remember seeing Good Will Hunting as a kid with my parents, who are, my dad's a mathematician, my mum's a computer scientist, and they both came out of that film being like whatever the narrative, they didn't give a shit. They were just like, what was on that board that he was writing? That is some basic mathematics. And it was the montage scene where he's supposed to be a genius, and the whole film was ruined for them because what was written on the glass window was just basic.
That wouldn't make any sense. I'm with you on the blackboards. What really drives me crazy, it's bad enough if the boards are just not appropriate, not the right level of difficulty or something. But sometimes people put stupid jokes in it. And I'm like, that's really bad.
And so when you're making a fiction, there's this big balance between getting the facts right and the story. And obviously this isn't a documentary, so it's there for the story. Were there notable facts in the film that to you would have liked to see a little bit presented differently?
Oh, that's interesting. There's so much to the story.
Yeah, because I would have thought, obviously, it's narrative purposes and Oppenheimer is the hero and the anti-hero, but I think it overstated his role as the first person to think of the atomic bomb.
Oh, no, he was not the first person
That's right. Tell us about
think of it. What you would generally credit Oppenheimer for is having the idea of bringing everyone together to do this task of the Manhattan Project. He's not even the head of the Manhattan Project. That's also sometimes people get that confused. He was the head of the Los Alamos Project, but he was not a head of the uranium separation that was going on at Oak Ridge or a head of the plutonium production that was going on in Hanford, but he was the head of the bomb assembly part.
If you look at the org chart, Oppenheimer's way further down than I think most people
He's not at the very
imagine.
top, for example, where Leslie Groves, the general.
Who's played by Matt Damon. That's right. But so going back to the film, a scientist from Australia had a little bit of a criticism, and I just wanted to get your thoughts on it. So Dr. Kirralie Rule, who's the former National Secretary of the Australian Institute of Physics, was kind of annoyed that the movie made the science seem so complicated. And she said, some characters even made comments like, quantum mechanics is hard. Quote, which I disagree with. It's only hard if someone hasn't explained it properly. As a physicist watching the movie, I think they could have been much clearer on the science involved. She said it made the audience feel separated from these scientific giants. As a scientist and a teacher, I think that's a poor way to represent science. It just continues to give the impression that science is too hard. What do you think?
Interesting. I'm not going to criticize this. I think the point is taken. They didn't spend a lot of time on the science and the math, but I do think they got the excitement of the science across. The movie is not a science lesson. It's an artistic choice. These people are telling a story, and it's about people, and they're relating to the audience. They have to make the show they want to make.
Now that you understand the creative process a little more, you're not so mad about, what was it, Space 99 anymore?
But, and again, even that serves its purpose. It gets people talking.
About science, that's right.
Like I say, I'm not the science police.
To finish up then, tell me, when you compare your work in the lab to your work consulting in Hollywood, which do you think will ultimately be more impactful?
It's funny to talk about the impact. These things are not mutually exclusive. Of course, if I read a physics paper, there's dozens of people that read it. If there's a line of dialogue in a TV show or a chalkboard in Oppenheimer, there's dozens of millions of people that will see it. So the scales are not commensurate. But in one case, my contribution is broad, wide, reaching, but thin. Maybe we get a word out there or a thought out there in the public and they go look it up. Where, of course, in science, I work on a paper for years, and so it's impactful in a different way.
Oh, thank you so much, David. Thank you for your time.
Thanks for having me, Wendy. Bye.
Well, that's it for Science vs. Oppenheimer. If you are going to see the film, bring earplugs. You got to protect those earsies because you're going to need them to listen to our next season of Science Versus, which will be back before you know it. If you miss me while we're gone, you can find me on TikTok. I'm at Wendy Zuckerman. You can find Science Versus on Instagram. We're science_VS. This episode was produced by Joel Werner and me, Wendy Zuckerman. We're edited by Blythe Terrell. Mix and sound designed by Bobby Lord. Our full credits are in the show notes. I'm Wendy Zuckerman. Back to you next time.